Welcome back, anatomy students. Today we're going to talk about the long bone. I have a femur here. I'm trying to get in the frame. So we're going to talk about the long bone. You might remember those are your fingers and toes, arms and legs, so basically your appendages. They're longer than they are wide. As with any anatomical structure lecture, our main objective is to be able to identify structures. So we want to identify some specific features of the long bone. A few bone markings I will introduce that help to participate in joints. So we'll talk about a couple specific joints. First, this is just discussing this graphic basically. The epiphysis are the two ends of the long bone. So epi means above or upon. So this is where you're going to have your articular surface. Articular means joint. So this is where it's going to join with another bone. Diaphysis, dia is through. So the length of the long bone is called the diaphysis. Up here in the epiphysis, there's some features I can identify. The articular surface, again, structurally, this is hyaline cartilage. That's the composition. Functionally, what does it do? It makes up the adjoining surface, so it's articular cartilage. And you find that at the ends of all of your long bones. Then you have the epiphyseal line. That's assuming that the bone has stopped growing in length. Until it has reached maturity, you have an epiphyseal plate right here when it's still growing longitudinally. We know that we find spongy bone in the epiphyses of long bones, and inside of there we also find red bone marrow. Red bone marrow contains red blood cells in various stages of development. We can see here the length of the long bone is made of compact bone, and it contains a canal down the center, the medullary canal. And inside that we find yellow bone marrow. The whole bone is covered with a tissue called periosteum, and inside the canal is covered with a tissue called endosteum. So endo is within or inner, and oste, bone, eum are tissue or structures. So it's literally the tissue inside the bone. And then peri means around, oste, bone, eum, tissue. So again, literally it's the tissue around the bone. So the epiphysis, we can talk about two ends. You have the proximal epiphysis and the distal epiphysis. How do I know which is which? Remember, proximal is closest the attachment of the body. And this end of the femur makes up your hip. So that is closer than my knee, which is this end here. So that concept makes this the proximal epiphysis, which is closest the attachment of the body. So mostly that is spongy bone, and that contains red bone marrow. It is covered with a thin layer of compact bone, and depending on the shape, it can make a different articulation. So this is a rounded shape, so it's going to fit into a cup-like structure in order to form a joint, and we'll talk about that in a minute. The distal epiphysis is the one furthest the attachment. Again, you'll notice it has a different shape, so it can participate in a different joint, and that would provide a different function, a different movement. So no matter what, if it's distal or proximal, its shape determines its articulation, its joint. So this rounded surface is called a head, rounded bony expansion on a neck. Just like our rounded head sits on a neck, the head of the femur sits on a neck. And this head would fit into a cup, and so this is a ball and socket joint, and it can provide a wide range of motions, right? It's going to go kind of in a circle. So you can practice that on yourself and see what kind of movement your hip does. So that's where you would commonly see it. Also in the shoulder. So the head of the humerus would also be a head, and it participates in a ball and socket joint. The condyle is the knuckle-like projection. So if you look at your knuckles and you look at the bottom of a femur, they have a similar structure, right? So this looks like your knuckles. Whoops, sorry. So that's a knuckle-like projection, and it takes place in a hinge joint. So this provides, a strengthening, a flexion and extension of the knee. Also at your elbow, you have the condyle, the knuckle-like projection, the condyle of the humerus, and then this is your forearm, and so you can see the hinge joint that it provides. So it's in a single plane, kind of like the hinge on a door. And there you see the condyles of the femur. And this would make up the condyles of the humerus. And this here, this is a fossa, a shallow groove. So also participating in that hinge joint right here, you have the olecranon fossa. So there's a groove that your elbow portion of your bone fits into, or the bony portion of your elbow. So the olecranon process fits into the olecranon fossa. So that groove right there, that would be a fossa, and that would be that groove right there. Okay, articular cartilage. So articular means adjoining, joint, something to do with joints, arth. So the articular cartilage you find in the ends of all of your long bones protects the surface of the bone so you don't have bone grinding on bone. And what it's made up of is hyaline cartilage. So that's a type of cartilage. And that is going to be covering the ends of the long bone rather than periosteum, which covers the rest of the bone. So it provides a smooth, slippery surface, decreases friction, and also in here we have the linear growth section, so that would be the epiphyseal plate. And once you're matured and no longer growing taller, like me, you have a epiphyseal line. So that you can find in that epiphysis. So the diaphysis is considered the shaft of the long bone. So this length of the long bone is the shaft. It's a semi-rigid tube. So this is a model a student of mine made. So you can see inside there's kind of like a tube there. So it's covered with periosteum. So this student put a separate tissue here. So peri around the bone tissue. Your bones grow in diameter because there are stem cells in your periosteum. And so as you're getting bigger and your bone is growing in this length, the periosteum contains those progenitor bones that create osteoblasts, which create matrix, and then eventually they bury themselves in their matured cells, and they're called osteocytes. So the periosteum is basically fibrous connective tissue. Many of you have probably had shin splints at some time, so when there's an imbalance in muscle strength or flexibility, the muscle pulls on that tissue, and that can be really irritating, and so the periosteum actually becomes inflamed, and you might actually feel that bump. And you can imagine that tissue is pulling then on your bone, so that creates an inflammation on the bone. In really severe cases, you can have stress fractures that way. The periosteum does contain a vascularization, so anywhere you want growth, you want blood supply, and so that's going to be found there as well as your osteoblasts. And then this is a picture of your compact bone, and you can see how that's a hollowed tube. We're going to talk about the medullary canal next, I believe. You can see how the periosteum can be actually peeled away. It's really fused quite tightly, but for the graphics, to give you the idea that it is a separate tissue, it's a fibrous connective tissue, separate from bone, we like to show it there. This is showing you a bunch of osteocytes in the cuna of the spongy bone that's found in the head. And then this is showing you all of these black dots here are osteocytes that are found in the compact bone, which is in the outer portion of the bone. So that medullary canal, again, I'm going to go to the student model found here. The medullary canal contains yellow bone marrow, and it's lined again with a connective tissue similar to the periosteum. It's called endosteum, inner bone lining. And so that also has osteoblasts that help with repairing damage to bone and new growth of bone. And then the yellow bone marrow, I think of yellow because it contains adipose, which is fat. And if you look at fat, it often has a yellowish tint. So its biggest job is really long-term energy storage. In youngsters, this, instead of yellow marrow, would have red marrow. And so that would be a site of hematopoiesis. Hematopoiesis is the formation of new blood cells, whether they're white cells, red cells, or platelets. So that's the end of my long bone lecture. Hopefully you can identify the epiphysis, the two ends of the long bone, the diaphysis, just the central shaft, the covering, which is the periosteum, the yellow bone marrow that is found within the medullary canal, the endosteum that lines the inner bone. You have cancellous tissue, spongy bone up here. You have compact bone found on the outside of the bone. You have hyaline cartilage covering your articular surface. You have nutrient foramens, which this model doesn't have, but you have blood vessels that are coming out of this as well. And we talked about the head of the femur, so it makes a ball and socket joint. We talked about the condyles, which make up a hinge joint. And we talked about the groove that is the fossa that also participates in the hinge joint. So that's all I got for you today. Thanks for listening.